I'm Professor Greg Pasternak, and I'm representing kind of like a consortium or team of 7 different institutions from around the Bay Area who are listed on this slide. And we've been doing a large Bay Area project, understanding streamside encampments. And I'm going to be giving you a presentation today showing you information about the Alameda Creek watershed relative to the Bay Area as a whole. First, I want to just get some facts on the table about what it is that we're all talking about in this topic. And so we can go to the US Department of Housing and Urban Development, just get some basic definitions. For example, to say that somebody is experiencing homelessness means that they lack a fixed, regular, and adequate nighttime residence. And within California, the 2024 January point in time estimate from a single day is that more than 187,000 people in California are experiencing homelessness. Of those who are unsheltered are having a primary nighttime location that is a public or private place not designated for or ordinarily used as a regular sleeping accommodation for people. In California, more than two-thirds of those who are experiencing homelessness are unsheltered. Nationwide, about a quarter of those who are unsheltered are 55 years or older, and only 4% are under the age of 18. Now, while these numbers are helpful to get some general context, you really have to be mindful that this is a significant undercounting. And we know that not only because you can look at the way counts are done, but because in some parts of California, we have people who are highly skilled experts, knowing their local communities, knowing their populations, and providing social services. And as a result, from their thorough, accurate counts that extend over just one day in January, we can get a sense that there really is some significant undercounting. And especially when we talk about along streams, then, how hard is somebody going to want to go, say, on a day in January to fan out through floodplain, forests, channels, blackberries, and find people? Within Alameda County, the 2024 point in time count led to a nice fact sheet to give you some context just more locally. And of the about 10,000 people who were surveyed, about two-thirds were unsheltered and one-third were sheltered. So that's fairly consistent. 78% of people were living in Alameda County before they became homeless, and 75% have lived in Alameda County for more than 10 years. So what does that tell us? It tells us that in fact, most people who are homeless in Alameda County are from Alameda County, essentially. We're not talking about people who like migrate from New York and are here or something, or are coming from other parts of the world or whatever. Like the vast majority have been living here for a long time. Within Alameda County, they also found that Black, African, and African American people have about 4 times their representation in the general population among those who are experiencing homelessness, which is far higher than any other group. Streamside encampments are those that are in the river corridor. Oftentimes streams in California are experiencing what are called like urban stream syndrome, where the channel has incised down and has kind of created this inset little canyon, so to speak. And then you have a riparian zone there. In other cases, like for example in Sacramento, I took this photo during an atmospheric river, and here's somebody who's like literally living in a flood channel trying to cope with the winds and rains that are coming. But you can see like there are people who are living along streams. We don't have good counts of the numbers, but they seem to be in the thousands and possibly the low tens of thousands who are living along streams. So that brings us to this project that I'm the lead PI on. So in late 2022, I put together a team of folks across 7 different organizations, and we start to think about this problem that here we have these unhoused people living along streams. The streams themselves are already under stress in terms of the in-stream and riparian habitats that they have, changes from climate and flows or other problems, trash, pollution. And then we have these natural disasters like droughts and floods, and together these produce a Venn diagram of just the normal concerns we have in urban stream management. Now put all of that into the context of climate change, which for California is generally going to bring hotter, drier summers and more intense wet season storms. Then the broad sort of questions is like, well, what will happen to all of this complexity and what do we do about it? So that was the context by which we formed our project, and we received from the state of California a climate action seed grant. And we're kind of focusing on questions such as who are unhoused folk living along streams? What is their vulnerability to wind, rain, and flash floods? Do we even know what kind of streams we have in the Bay Area? What are those habitats? What flood regimes we have? And of course, people study all of these questions within their own local context, but this project is looking throughout the whole 9 county SF Bay Area. Our team consists of two PIs from UC Davis, two from San Jose State University, three resource conservation districts in our area, UC Agriculture and Natural Resources, and then a nonprofit, Safer 3. Our project has both social science and natural science research components, and then looking at the interweaving of those two. The social science components are generally being driven out of San Jose State University, and they include surveys of residents living in camps along streams, assessments or observational surveys of the condition and structures within the camps, and then a rapid trash assessment. We also are looking at pollution, public transit, and land use context of camps. So where do these camps fit in with what we can learn about civil infrastructure and other things? In the natural science side, which is generally being led out of UC Davis, we have a hydroclimatologist who's been looking at compound rain and wind extreme events under contemporary conditions and two different future scenarios. We've been carrying out extensive geophysical surveys, stream classification, and data science, including machine learning prediction of stream types. And we're carrying out mechanistic studies to understand what the different types of streams experience with fish, riparian habitat, and the flooding regimes for sort of the natural hazard component that's facing people in these different settings. And then all of these data are being brought together in different individual study components. For example, being able to predict throughout the Bay Area, what is the probability of an encampment thinning location? What's the probability of different kinds of fish habitat for different species and life stages? Or what are the probabilities of flash floods of different magnitudes? Um, we're also looking at social ecological vulnerability for different people on a census tract basis generally. And then what is the resilience of different communities to recover in the face of some sort of problem? We also have a very strong outreach component to our project. We've collaborated in 23 camp cleanups, and generally we do our interviews during those cleanups and our site observations. We've also been working with a private foundation. We've shepherded $134,000 to 14 California-based nonprofits. We hold biweekly meetings with our resource conservation district partners. We've been involved in blogs and news stories. We've submitted a Cal EPA proposal, hopefully for the future, to provide a flash flood alert system specifically for encampments. And we've done extensive engagement throughout the community in the Bay Area. And we're definitely looking for more of you who have not heard about this project, who we haven't had a chance to talk to. Please feel free to contact me, and I'd like to have more discussions and learn about what you all know. But most importantly, like my view is the lead PI is that we need to treat the Bay Area as a comprehensive system. And I like to turn the Bay Area on its side. You may notice we're looking at it north in this little bit funky direction, but it makes it fit the slide better. And it also gives us a little bit different view. And that's sort of what this is all about. Like, it's great that every stream in the Bay Area has a friend of the such and such stream council and things like that. We really need that local passion and love for each stream. But we have to have data and understanding to think about the system as a whole, and so that we can learn lessons like, hey, is something going on in Sonoma that we should be thinking about in Alameda, or something in Alameda, something that should be doing in San Mateo? And what is that information and knowledge? So this map just illustrates the stream network that we're focusing on. The orange dots show the geophysical 164 sites, and then the black dots are the more than 80 or so campsites that we're aware of. And we know there's more out there, but you can see that within Alameda Creek watershed, we certainly haven't neglected it. We have a fair amount of sampling that's taken place throughout that area. So throughout the project, the collaborators from San Jose State University, led by Professor Costanza Rampini, and with her master student Abby, they have been conducting now 300 interviews with residents throughout the Bay Area. They've done a fantastic job of getting around to all the different counties and meeting with people. And that's led to some just basic insights about what are the lives like and why are people there. Most camps that they observed were small, with about 10 to 24 structures, with Santa Clara County having the largest camps. There's a lot of semi-permanent structures and communal areas, and these photos sort of illustrate the kind of things that you see out there. You also see, depending on what kind of stream type they're in, excavation. So here's a case where in the San Jose area, there's actually a landfill, and the bank of the river is literally sort of like cohesive drywall, like sheet of drywall. And so somebody has just carved out a cave into that and then built their home right in there. And we've seen that, it's not uncommon to see that. Also, many people who we've interviewed are older than 50 years old, even more strongly than what was reported nationally. In the Bay Area, we're seeing a lot of older people who are living along streams. There also are a lot of pets and feral animals at campsites. Another thing that we've seen is like, well, why? When we ask people, why do you choose to live along the streams? Like, why don't you go to the shelters? First of all, many people say that they value a closeness to nature, that it feels like camping, and that they're also out of sight and secluded. They feel safer in that. The canopy cover that is present in along many streams helps to provide a cooler setting than being out in the hardscapes of a city. Typically, people are not drinking from the river, they're not fishing from these streams. Um, but when they think about the so-called shelters that they're supposed to go to, that the state of California and local communities are providing, these are viewed as unsafe. They don't allow people typically to bring their pets or their belongings. People have a lot of stuff they don't want to give up. And if they just try to hide it, there's a chance that it's going to get stolen. There's also a lot of rules that don't fit with how they live or treat them respectfully as adults. So we see people growing gardens out along the streams or having, communal campsites. When we talk about climate and natural hazards, we've learned a lot from them as well. For example, many people don't even bother to find out what the weather is. A lot of people don't even have cell phones, or if they have them, they're not charged because they don't have a power source. So they're just taking the weather as it comes. Most people never receive early warnings about heat waves or flash floods. It's just whatever they hear word of mouth. Almost none have gone to a cooling center or a warming center to protect themselves against extreme weather events. And so there's, like people just don't even know that that's out there. Or, for example, some counties have emergency systems like websites, alerts you can get through apps or through your phone, but these are not generally known or adopted in this community. When it gets really hot, people tend to just move into local stores to try to, get into some air conditioning. But when it's raining, they move into their tents. People also are, used to like living with floods, so they just try to, beef up what they've got. They put pallets under their tents, put more tarps, or in some cases move to higher ground. Like people aren't generally in the riverbed, but as you've seen from some of the photos, they can be right along it. Almost everyone has experienced a fire, and so like there's a very significant chance of fire taking place in camps, generally not because of cooking, but in fact, it turns out that there's a high risk of people causing fires deliberately. For example, if they're mad, if one person is mad at another person, it can happen that they choose to try to burn them out. So, with those insights, then, what is the natural environmental context of these sites that we have to be mindful of that as people continue to increase in their use of streams for their main living condition, then what are they up against? And so we've been focusing on what are called compound wind rain extreme events. Of course, the heat and dry side of the year is important too, but that's not the focus of our study. We're focusing on the wet season. And there are different risks associated with wind or rain, and then they can work together. So rain generally drives people into whatever ad hoc shelter they have. And then once they're in, then they're at risk because they're not going to leave. So that means that, if a flash flood comes and they're locked into that spot, what is their ability to get out? What is that hazard they're going to face? Also, as I've toured sites, like one thing you see is it can be really, really muddy throughout an encampment site during the wet season. And so now you've just got mud everywhere. It's very slippery, which creates a fall hazard. And it just makes everything, less clean and unsafe. On the wind side, wind, once you have some rain, that can really loosen the soil around the roots. And so large trees with shallow roots can become highly vulnerable to toppling over during winds. And we saw that in 2017 and in 2023. For example, here in the January 5th, 2017 news story, winds topped 50 miles per hour in some areas. A woman was killed in the East Bay suburb of San Ramon, struck by a falling tree. So, yeah, tree fall is a very serious problem. So, really, there's a compound effect when wind and rain go together. And so, at UC Davis, postdoc Nikhil Kumar has done a really fantastic job of analyzing the compound wind rain extreme events. And while there's a lot of data, I just want to show you this one slide. This shows the Bay Area again turned on its side. And I've got the Alameda Creek watershed shown here in a bolder black outline. So this is the GridMet data, which is satellite data with 4 kilometer cell size. And what the colors here are representing is the return period in years of compound events. So it's a little bit confusing, but a long return period shown in blue means that they're not happening as often, every 2 to 3 years. But when you're in red, it means you're basically having like two of these events each wet season. And when you look at the epicenter, we see that Napa County is an epicenter of this, and then the Alameda Creek watershed and in southern Santa Clara County, these are the epicenters where having two of these events a year is taking place. Now, we've also done an analysis to see, well, where does that map to with socioeconomic vulnerability? And to do this, Dr. Kumar turned to the American Community Census, which is a national data set, and it includes lots of variables. In this case, we're focusing just to show you one snapshot of this, the overall social vulnerability index by census tract from 2018 to 2022. The black dots here are the known past or present encampments that we've been tracking. And what you can see is that within the Alameda Creek watershed, that there's a very good tracking here between areas that have a high socioeconomic vulnerability and then where these camps are. I mean, pretty much that's true throughout the Bay Area. Like there's no question that those are overlapping. But you can see that there is a cluster of these in the Livermore area. And while there is a lot of socioeconomic vulnerability when you get into like the coastal Bay Area itself, that there aren't as many camps there that we've recorded. So now what if we overlay these together? Oops. So what I'm overlaying here is in like the red hatching is this area with the highest frequency of compound events overlapping on the social vulnerability index and the encampment locations. And you can see that it is more towards the valley side of things where we're now getting this joint effect of these compound wind rain events together with where there's high socioeconomic vulnerability and where stream side encampments are located. And so this would then tell you, like, hey, if you're working on policy, while all areas sort of need help, you really might want to take a close look at this Livermore area within the Alameda Creek watershed because I get it. Like, basically, when you're in an area that has relatively low tree canopy and you have very high winds blowing through, like, I have observed what happens in the camps. What happens is that the plastic just doesn't hold together, like the rain can be washing away any sort of paper materials, like the wood that's used to sort of hold down plastic, it all falls apart, people scurrying around, and now you've got a big storm and a flash flood coming through, and there's just no resilience. I mean, people are in just dire, dire circumstances. So yeah, that it really all creates that juxtaposition of concern. Just as another example, Professor Serena Alexander has been leading two grad students, Jeff and Bennett, at San Jose State University. And they've looked at where camps in Contra Costa and Santa Clara counties are relative to Cal Enviro screen scores, where we have the worst, like the most highly polluted areas, which are shown in red here. So sorry we don't have this analysis for Alameda County, but it's pretty similar to the social vulnerability index. And what they found statistically is that camps are 3 times more likely to occur in highly polluted areas than would occur by random chance, with a greater than 95% statistical confidence. What about what's going to happen in the future? So we've analyzed, of course, there are many climate models, there are many emission scenarios that are out there. I'm going to show you the ensemble result of models coming from the CMIP6 data set, which is the most recent data set, with the high emission scenario. Now, maybe I'm just sort of cherry picking, but I can tell you this, conditions are even worse in the low emission scenario for the Bay Area, actually, for whatever reason. So the high emissions scenario, and of course, the way things are going in the world, it doesn't, the high emission scenario looks pretty feasible. Any case, when we look at this, the area in yellow is showing that we'd have 0 to 20% more frequent compound extreme events over the 30-year period that's upcoming. And with spots within the Alameda Creek watershed having 20 to 40% more frequent events. So yeah, we Alameda Creek watershed, for whatever reason, is a hot spot for both current conditions and future conditions. I mean, I understand why that is from the hydroclimatology. I mean, once you get away from the bay itself, then you're into a place where there's just far less resilience in terms of what's going on with the weather, right? You're into this drier, windier, more extreme setting. And so that's what's happening basically. Okay, so moving on from the hydroclimatological context to the streams themselves, we've done a pretty significant field campaign in 2024 in which we selected sites throughout the Bay Area using a new framework for how to select sites in environmental science that we developed It's a machine learning guided, it's called human in the loop site selection. What does that mean? It means we've taken pre-existing data sets from around the Bay Area and we fed all that into different machine learning models to then help us find out like what are the likely stream types that are there and what are the things that we just really don't know about the Bay Area to make sure that we would go visit sites to sample the known knowns and the known unknowns. And that only leaves the unknown unknowns, which we tried really hard. Like I spent hours scouring through like all over on Google Earth. Like, hey, is there some stream here that we're missing? Like there's some type, what's not, what have we missed? And then we would add more sites over and over again iteratively until we got to this 164 sites that seemed to do a really good job of accounting for the uncertainty in the stream classification. The colors of all these dots show the 12 different types. The colors in sort of blue, green, gray, black are the natural channel types, and then the purple, red, orange, and gold are artificial channel types. So that's another thing is that most studies that look at stream types don't even look at artificial rivers, like they don't even exist. But why would you ignore that? I mean, so much of the Bay Area is in these stream types. Like we have to be mindful of these artificial streams. So we now have a stream classification. I don't really have time to go about it. You can see that we do have representation of the Alameda Creek watershed for that. So I want to show you just some of the preliminary results. There's a lot more work to do from this data set. But I want to first emphasize the difference between natural versus artificial stream types. So we define artificial streams as those with more than 50% of the site has an artificial shape or composition for its bed or banks. Whereas natural sites, they can be severely degraded, they can have urban stream syndrome, but more than 50% of the site has not been directly modified by human activity. And I think you can see the significant difference between an artificial river, such as in the urban and agricultural setting, versus say like an urban stream syndrome, which at least still has riffles and pools going through it, and a relatively wild site up in Sonoma County. So if we look at the Bay Area as a whole, this is a preliminary map showing the prediction from machine learning of where are natural versus artificial streams based on 164 training sites using 151 predictor variables in a random forest algorithm. I say this is preliminary because we're still obtaining data with more training sites and we're still fine-tuning our predictor data set. But I think there are some lessons already here, even if the details change. So for the Bay Area as a whole, and then focusing specifically on Alameda County, the other thing I want to show you is what's in this cream color are the valley floors. So I have a master's student who has written a novel algorithm that has extracted all the valley floors for the state of California, and I'm just showing that for the Bay Area. So what fraction of streams are artificial? For the Bay Area as a whole, about 17%. And then in the Alameda Creek watershed, 13%. So it tells you like, yeah, Alameda Creek is generally a more naturalized catchment relative to the Bay Area as a whole. What about when we look at valley floors, where the valley floors are larger than 5 square kilometers in area? So not just like, a confined river happens to have a channel in it. We're not going to call that a valley floor, but for where we actually have some width to the valley floor. So 28% of streams on valley floors in the Bay Area are artificial, and 26% in Alameda Creek watershed. So in general, actually, Alameda Creek watershed is fairly representative of what's going on in the Bay Area as a whole. Now, what about encampments? Where are the encampments? Well, 47% of encampments among that data set that I've been showing you are along artificial streams. So you think, well, that's about 50-50. Half are on artificial streams and half are along natural streams. But when you consider that only 17% of all streams are artificial, you have to take the 47 divided by 17, and you find that we have 2.8 times random chance alone, a preference for artificial streams compared to natural streams for where encampments are located. Also, 93% of encampments are on valley floors. So people are not kind of going up into steep areas and really, really hiding away. And that's because they still want to remain close to urban centers where they can get services and fill their needs. So the last step of what we're doing right now is we're engaged in process-based studies. So stream classification can be useful as long as it isn't taken as dogma. But within the stream classification, like what are the processes that are unique to each stream type and how would that affect encampments? So we're going through a process of posing questions and hypotheses. We are going to have somewhere between 40 to 100 sites that we're going to be modeling. We've planned on 44 sites, four for each stream type, but we'll see where that goes. We've been creating the digital elevation models for those. We'll be doing hydrodynamic modeling and then doing statistical testing of hypotheses about fish habitat, riparian habitat, and encampment conditions. And so, in conclusion, what do we know so far? So, I'm not going to call this so much conclusions as like prognostications and insights from our project. While government behavior is highly unpredictable, but look, unless somebody builds 3 million new homes by 2031 and the government gives massively more money towards what people need, then you just have to expect more people are going to be living along streams over time, including in the Alameda Creek watershed. Also, counties are taking very different approaches to streamside camps. Contra Costa is being the most compassionate in their approach, in my opinion, while others are being extremely punitive. And I think you've seen about that in the news. One of the challenges that we really face is that we have in the environmental sector, a lot of people who are here, and then the social services sector. And they have some overlap, but historically, they really haven't had to work together to find common solutions. And that's really what we need to do now. And finally, I think like our project has shown that universities working with local governments and nonprofits can take a system as a whole, value what each piece can do. You know, different groups have different capabilities and draw on those different strengths to monitor what's going on and guide future actions. Okay, that's the presentation. Thank you for your attention.